in UPC, and also I'm organizing, together with my friend, the Challenge Native workshop. It's an 8 hours workshop on giving developers the hints how to develop web applications which are able to challenge native in terms of performance. So if you're interested in this kind of workshop, you can visit our website, there's information there, and probably we'll make a workshop near your place. So yeah, you can always contact me this email on Twitter. Yeah, in UPC we developed software, JavaScript, suddenly, JavaScript for embedded systems, and this kind of boxes. Actually, we have a few more generations now, but this is the latest you can get here in Netherlands. And software for it, our operation system is built with JavaScript. Of course, it's compared in terms of performance with mobile systems. So we usually put a lot of efforts on optimizing our stuff, on making our HTML very, very performant to give you pleasure to use our products. If you say, I don't care about this kind of performance, it's not actually true, because you will have all this stuff. And yeah, mobile web is growing, and you always should keep eye on mobile web. So performance is very important. And the biggest problem of performance in web applications is that DOM is slow. So DOM, as you know, if you ever try to inspect any DOM element, so DOM is slow. DOM is a very complex model. So every element in an image has a bunch of properties, about hundreds of properties or something, which browser need to keep in the memory, change, react, and if you touch one element, you start a ripple of events of a whole document, so it really takes a lot of CPU. DOM is really, really slow. Yeah, let's see how it happens in DOM. So when you want just to display image, you need a few steps. You need to create image tag, load file, append image tag, so that browser calculates styles, which could be quite hard to even then calculate position and size, and then display image. So if you try to display the same with canvas or WebGL, it will take only 2 steps. So it's a load image and draw image. So actually DOM is slow because it's quite complex model. And if you try to get maximum performance in your mobile application, you would like to avoid DOM, at least for animations. So do anybody of you knows about translate ZPack?
About what?
Translate ZPack, yeah. So translate 3D, so a few of them, few of you know this hack, know that CSS can do GPU acceleration, but the trick is that if you return to the previous step, it optimizes only the last step, and it's still DOM. So if you want to move it, it still needs to recalculate position, it still will fire some events, and so on. So DOM is always slow. And DOM is hardly predictable. So if you compare timeline recorded for to put some details, it's recording from same component. It's carousel, one of them built with DOM, but it's absolutely the same look and feel. And the one is canvas. So with canvas you can easily predict when your system makes some calculations, some rendering, and so on, because you manage it, because you say, please draw image, and for DOM, browser decides when to do that. So DOM is hardly predictable. HTML avoids using DOM at all. So it's a first big thing behind it. So when you do some interaction, you do not work with DOM. It doesn't touch DOM, so it doesn't change all this model. And it's actually much faster only because of that. There are also one thing. Who knows what's it? No, any assumptions? Yeah, that's a graphic card. So graphic processor unit. It's actually a very expensive card from past. I don't know which one, but it's illustrates what graphics processing unit very well. And it is quite powerful system with a bunch of memory, few processors, which are aimed for managing images, how they apply to each other, and to manage graphics. To give you a hint how CPU differs from GPU, let's ask guys from Mythbusters, you know these guys, to show you this. This robot will paint a picture as CPU do it.
3, 2, 1.
Yes, CPU do a lot of calculations to put every pixel. It actually considers where to put pixel, and it takes a bunch of time. This is a GPU, yeah. So GPU is heavily optimized, displaying things quite fast and in a quite performant way. And it's usually very efficient to use it for HTML. Modern GPUs can manage millions and millions of textured surfaces. So we can treat it as millions of these or millions of layers. So it is not a big deal for modern GPU, even a mobile phone, to manage thousands of them. Why so many? Because for some things, millions of surfaces are not enough. If you see for this model, it's still not perfect. So you need really millions of polygons, millions of surfaces to make a pretty result in a game or something. So yeah, let's see what modern GPU can do actually. It's not that funny as Mythbusters, but it gives good insight of the power of GPU. So I believe that the hand of this guy consists of few thousand of surfaces. Only one hand. And the whole scene is probably millions and millions. And we have smooth 60 frames per second here. And when I see that some web application stucks and have some chance, when you move a one div over the screen, I say, wow, how it happen? Mostly it happens because it doesn't use the power of GPU. Because actually, yeah, for modern video cards, it's not a big deal to manage it. Yeah, so we shouldn't use DOM, we should use GPU, but why we don't do that? Why we still do not render on GPU? Why we don't use WebGL? WebGL is a possibility, is an API to use GPU acceleration and all these amazing effects we see, these explosions or whatever, or shaders, reflections. We can't use them in DOM, but we can use them via WebGL. And WebGL is super performant, so let's go to a test. So let's release some bunnies. We can treat every bunny, so we see it's a web browser, so you can treat every bunny as a div. And we'll start to increase their number. So at the moment there are 10,000 bunnies, 20,000 bunnies, 25,000 bunnies, 30,000 bunnies, 40,000 bunnies, and now it starts a bit sluggish, but still we have 60 FPS. Sometimes it's like, but can you imagine any website with 40,000 of divs? I suppose never nobody even can imagine that. So 40,000, and this is something we can't reach using a DOM model. We can't reach that using HTML. So yeah, bunnies are cool, a lot of them. Let's return to presentation and why we don't use this content. Yeah, because WebGL is very verbose and complicated to use. Also, you have no abilities to style. So how it works actually, and why we don't do that? Because this actually equals commands. This one is 3JS library for WebGL, and this is HTML. Will you use it for displaying an image? No, never. You will say, sorry, I'll just avoid many divs on the screen. I will have some janks in my application. I don't need 60 PPX. And come on, just leave me with my image tag. Yeah, that's a bad part. But here, HTML.jl is a game changer because it helps to make it like that. So all these commands, which you just seen in a 3JS side of the screen, you can substitute with a simple call to the same HTML. Just wrap it with HTML.jl. Yeah, it works. Actually, there are some things behind it, and we'll dive into them. So yeah, you can call it via web component as a web component by writing some content, or as a jQuery plugin by casting a HTML.jl magic to it.
So that's kind of preprocessor for this WebGL?
Kinda, and now we'll dive into details and how it works. So yeah, the flow is quite simple. In terms we can rely on it, and web browser, you know what web components are. So web components is the next big thing. So you can put some custom text into your application, and they could have any logic inside or whatever. So yeah, it's just some great piece of logic just hidden behind this custom element. In this case, element name is HTML.jl. When browser sees HTML.jl is on the page. Well, okay, I have HTML.jl, I have some library behind it. Let's rasterize content of this div or whatever, any element. Let's display it on WebGL surface, and then if element is changed, we all rasterize it once more. If change